these consecutive numbers. So in order to get a difference, you get a difference between two numbers. For example, I've got a difference between this number and that number, difference between this number and that number, difference between that number and that number, that one and that one, which is 3, 3, 3 all over. So to get a difference of each of these numbers, you wanna say, for example, here, the difference here we got here is from 7. It's from 7 minus 4. And then to get the next one, you'd say 10 minus 7, 13 minus 10, 16 minus 13. This is how you find the difference every time. This is how you find the difference in number patterns every time. You look at the next number, you minus it from the previous number, next number, previous number, next number, previous number, next number, previous number. So that's what you do. You subtract the next number with the previous, the next number with the previous, next number with the previous, the next number with the previous. So that's how you subtract to get the difference between each number. So this is a linear number pattern. Okay, this is a linear number pattern because we got our first differences and they are constant. So the general term of a linear number pattern is as follows: Tn is equal to Bn plus C. In a linear number pattern, we have the first term, which is B plus C. This is the first term, so that means this is B plus C right there. And then we have a constant difference. Like I said here, I got 3, 3, 3, 3 all over, so it's a constant difference because it's 3. It's a constant difference because it's 3 here, 3 there, 3 there, 3 there. So that's our B right there. B plus C right there. And then we also have the general term Tn is equal to Bn plus C. Like I said, moving on, we have this number pattern over here: 1, 5, 12, 22, 35. As you can see here, the difference between this number and that number is 4. Difference between this number and that number is 7. Difference between this number and that number is 10. Difference between this number and that number is 13. Can you see that there's no constant difference here? So we cannot have a linear number pattern there. We cannot have a linear number pattern there because we cannot have B plus C or B because there's no constant difference here. So this cannot be, we cannot have a linear number pattern when we have this type of situation here. So we move on. We find the constant difference between the differences of the first terms. So the difference between that one and that one is 3, that one and that one is 3, that one and that one is 3. So we now have a constant difference. Now, you see this type of number pattern is a quadratic number pattern because it has second differences. These are the second differences there, and then those ones there are the first differences. So if you see a number pattern with second differences, or if a number pattern gives you second differences, it's have a second constant differences. Okay, second constant difference, then it is a quadratic number pattern. Like I said, it has first differences which are not constant. These ones, these are the first differences. And then it has constant second difference right there. Difference. The first differences form a linear number pattern. Okay, so the first differences form a linear number pattern. Let me explain what that means. So these first differences form a linear number pattern because now look at what the differences between these numbers give us. 3, 3, 3, right? So what do you notice? Constant difference, linear number pattern. Remember what we got on the previous number pattern? It looks something like this. So which means in this right here, not here, from here we have B plus C and we have B for linear number pattern. So for linear number pattern we have B plus C and B. So wherever you see constant differences, and before that these numbers like this, and they have constant difference, then you can have a linear number pattern. But overall the whole thing is a quadratic number pattern, because over here we don't get constant differences, so we have to go further and find constant differences, which are second differences that are constant, which is why this is a quadratic number pattern. But if we got our constant differences between these numbers, then we would have a linear number pattern, nothing else. Our linear number pattern occurs here because we have differences between these numbers. Otherwise it wouldn't be a linear number pattern. So what I'm saying here is this is a quadratic number pattern, but it also has a linear number pattern within, because there's b plus c there and there's b. So since there's a constant difference, then that makes this portion here a linear number pattern. But the whole thing is a quadratic number pattern.